students, today we are going to see some more important questions in that one among how to convert ethene into formaldehyde. That is nothing, alkene into aldehyde. You know what method we are following? Ozonalysis. Ozonalysis. Okay, ozonalysis O3. It's very interesting, you know. Now let us go for this question only. CH2 double bond CH2 ethene combined with ozone, you are getting what it is? Ozonide. You will get that cyclic compound of ozonide. You see, ozone. What is the speciality of ozone? You know, this ozone will break that both the bonds. So automatically you will get that what it is. That bond breaks in that place which will go and attach with oxygen. That means here CH2, here CH2. These both connected with the oxygen. 1, 2, 3. So 3 oxygens are there along with the 3 ozone. Yes. Okay, 3. Ozone, it is O3. Yes. Now you are getting what is the name of this compound? Cyclic compound I mentioned. And this is ozonide. Ethane cyclic compound of ozonide. Ozonide. Right? Okay, now this will not be quite. This is an intermediate compound only. So what happened? Hydrolysis takes place. Now when you're going for hydrolysis, what happened? Now the bond breaks here like this. As I put it in this line only, you will come to know that idea CH2O. What is it? CH2O? CH2O. What is this? Formaldehyde. Yes. Before I could tell only you are understanding this point. Aldehyde, formaldehyde. Yes, you got. Okay, here one CH2, here one CH2. Yes, you are getting. Now, actually, what happened? This H, OH, you know. So, what happened? This is actually here one O and here one O. And this hydrogen. So, H2O2, you will get it. H2O2. Okay, H2O2, it is a hydrogen peroxide. Hydrogen peroxide, it is a very good oxidizing agent. So what happened? Aldehyde again further oxidizes. Again it is converted into carboxylic acid. To avoid that only, they are adding what it is? Zinc. We want only formaldehyde. We don't want carboxylic acid. Suppose if you want carboxylic acid, you no need to add that zinc. Directly, you will get that what it is aldehyde and then carboxylic acid. Further it forms. Why? What is it actually? Reason. Here actually, what it is? Hydrogen peroxide forms. Here hydrogen H2. Here one O. Here one O. O is free now. This is CH2, CH2, this O, it is free now. So that O combined with here, you will get hydrogen peroxide. Hydrogen peroxide, it's a very good oxidizing agent. So that is aldehyde again further oxidized to form carboxylic acid. So to avoid only, we are adding zinc. Hope you're clear how to convert ethene into formaldehyde. Yes? The same kind of question only. Propene to acetaldehyde, butene to propanaldehyde. You see, propene to acetaldehyde, the carbon number will be lesser comparatively the first one. Okay, now let us go for that propene. CH3, CH, double bond CH2. This is propene combined with the ozone. You are getting the same ozonide. What it is? There it is ethanide. That means ozonide, ethene ozonide. Here propene ozonide, cyclic compound of propene ozonide. That's all. Okay, now the same way here CH3. Here, where the bond will break, wherever double bond is there, in that only. So, ozone speciality, where there is a double bond, there it will collapse. So, what happened here? CH3, CH, here O, and here CH2 combined with O. So, now you see here only, so that bond breaks and then you will get what it is. Ozonide, this is a cyclic, propene cyclic ozonide. Okay, now this will be undergo with the hydrolysis H2O, and going for hydrolysis, what you will get it? H2O2. So this H2O2, it's a very good oxidizing agent, so it will converted into carboxylic acid. That means here you will get acetic acid, acetaldehyde, and then Again, at once you will get acetic acid. To avoid that only, what we are adding? Zinc. Okay, now why do we add zinc? I think you will come to know. So here what it is, the bond breaks as I put the ring, you will come to know CH3, CHO. So CH3, CHO. We want acetaldehyde. No, yes, we got it, acetaldehyde. And here one more free as you take. So CH, what it is? CH2. Oh, what it is? Formaldehyde, formalin, formaldehyde. I hope you got an idea. So here propene it is there. What it is? Acetaldehyde, ethanaldehyde. So this is acetaldehyde. It's a common name. Ethanaldehyde. Okay. Now next one, what it is? Butanaldehyde. Hope you're clear with this. Propene to acetaldehyde and formaldehyde. It's a free of cost. You are getting formaldehyde. Hope you're clear with it. Okay. Now next one, what it is? Butene into propanaldehyde. What it is? Butene, CH3, CH2, CH double bond CH2. Yes, you got it. Okay, now along with ozone. I think you got an idea how to do that. By this time, you people can do that. Okay, CH3, CH2. Wherever double bond is there, in that only the bond breaks. So that means CH, here CH2, you no need to put it here bond, here you have to put it like this, and then ozonide formation. Okay, now here you are going for what it is, hydrolysis process, H2O. So when you go for hydrolysis process, H2O2, it releases hydrogen peroxide. So hydrogen peroxide, it's a very good oxidizing agent. So it will convert it into directly what it is. For the oxidizes, you will get carboxylic acid. To avoid, we are adding zinc. In the question, they asked aldehyde only. So directly we can go for that. Okay, now what it is? Now the bond breaks. Now what you will get it? CH3, CH2, CHO. Yes, CH3, CH2, CHO. What is this? 1, 2, 3. Propane, propanaldehyde. Okay, the next one. CH2O. So that means CH2O means what it is? HCHO. Formaldehyde. That is what I just mentioned. Hope you're clear with this. Okay. Now, suppose butene the same, but two butene CH3, CH, double bond CH, CH3. If it comes like this means, what happened here? What is the product you will get it? O3. You will get what it is? CH3. Wherever double bond, there only it will break, right? CH3, CH, here CH, and O connected with this to oxygen and what it is? Yes, you are getting what it is? Cyclic compound. Yes, cyclic compound of ozonide. CH3. Yes, CH3. You got it. Okay, now again you're going for hydrolysis, H2O. So you will get what it is. It releases H2O2, hydrogen peroxide. So hydrogen peroxide, it's a very good oxidizing agent. So you will get what it is. Further oxidizes, you will get carboxylic acid too. So to avoid, we are adding zinc. Okay, now what happens? CH3, CHO, CH3, CHO. So that means CH3, CHO. What it is? Acetaldehyde, ethanaldehyde, so two molecules. So butene converted into acetaldehyde, butene converted into propanaldehyde. There are two questions are there. You please remember where you have to put that, where you have to place the double bond. Please remember. Hope you're clear with this. Now the same concept only, but alkene converted into ketone. So long we have seen what it is. Alkene converted into aldehyde, but alkene converted into ketone in the presence of what it is? Ozone. How is it possible? Yes, I will give this 2-methyl propene. What is it? 2-methyl propene? CH3, C here CH3, double bond CH2. Yes, this is 2-methyl propene combined with what it is? Ozone. Yes, you will get what it is? C here CH3, here CH3 bond breaks right here. Now here CH2, here O, this O, here also O, this is connected. Yes, the bond breaks means whatever it is, I just put it slanting way for you to remember. Okay, now what happened? Hydrolysis, H2O. So here also minus H2O2. It releases hydrogen peroxide. You know very well for what purpose we are using zinc. To avoid that what it is, to get that carboxylic acid. It may undergo with that hydrolysis, sorry, oxidizes. Further you will get carboxylic acid for that only. Okay, now the same way bond breaks. Now I think you will come to know. See, here CH3, here CH3, double bond O. CH3CO, CH3, what it is? Acetone, yes. Ketone, yes, you got it. What it is? 2-methyl propene into acetone. Alkene converted into ketone. So in this way, you please remember. Suppose if such kind of related question comes, you please remember alkene converted into aldehyde as well as ketone. Ketone, how do we get it? Like 2-methyl group attached with it. Okay. Hope you're clear with that. And next one, what it is? H2O. What it is? CH2O. Sorry. CH2O. Formaldehyde. Formaldehyde is also known as formalin. That is, you know where you will find. Just to go to zoological lab. There you will find. You know they'll put that all the specimens in that formalin only. Okay. You just check it. Hope you're clear with this ozonalysis, how to get that, what is the method of ozonalysis, how to convert alkene into aldehyde, how to convert alkene into ketone. These are the two questions are very, very important. Hope you're clear. In that reaction, I forgot to mention one thing. Zn, why do we add? Okay, Zn plus H2O2. You will get what it is, ZnO plus H2O. It is reductive ozonalysis to for that purpose. You know very well what purpose we are adding zinc. So you will get zinc oxide and water. So that this is the reason we are adding zinc to pull that oxygen. Hope you're clear. The next one more important question, how to get acetaldehyde from ethyne? That is a concept, alkyne into aldehyde. Alkyne, ethyne, what it is? Oh, what process? What is the method we are using? Hydration process only. Hydration process. So hydration process means we are adding water along with dilute H2SO4 in the presence of mercuric sulfate. Yes, come to this CH triple bond CH, ethyne only they mention. Ethyne, it is what it is? CH triple bond CH. We can say acetylene also. Along with water in the present, it's actually dilute H2SO4 in the presence of what it is? Mercuric sulfate at 338 Kelvin or 65 degrees Celsius. 65 degrees Celsius. What is the process here for? What you are getting that product, you know? OH. Suppose if it is like this means one thing which will, the bond breaks, right? So one hydrogen which is going to attach that this one OH which will go and attach. So that means here Marconi-Scoff's rule we can bring it over here. Okay, both are similar. It's a symmetrical only, so we can't say that. But when we are going for propanoldehyde, this is acetal alkyne. That means ethane. We can say this. Suppose propine comes, we will consider that. Okay, actually ethane will give acetaldehyde, whereas propine, butane, like such kind of things and all, you will get ketone only, you will not get aldehyde formation. Please remember this point. Okay, now what happened here? CH2, only one bond breaks. CH2, CH, here OH. So that means here what it is, CH2 double bond CHOH, alcoholic form. Now here actually tautomerization, that is ketoenol formation. You know very well, same molecular formula, but the functional group attaches in a different way. So that is tautomerization. So here that is going to take place. Here OH it is there. That means it is alcoholic group. Whereas here CH3 CHO. So in this way, it will form CH3, this hydrogen, if it goes here. So automatically CHO. So this is ketoenol tautomerization. Okay, now here also you can put it C double bond OH. Now I think you got carbonyl carbon, you got it? Carbonyl carbon. Yes, here OH, here carbonyl carbon. Hope you are clear. So this is actually tautomerization. Tautomerization. Hope you're clear with this idea. Okay, now as I mentioned, this is alkyne. That means ethine into acetaldehyde. Now propine. Let us go for it and find out what is the product we are getting. Okay, propine, butane and all. What is the product I mentioned? Ketone. Come on, let us go for it. The same concept here, propine into propanone. Okay, propine, what is the formula? CH3 C triple bond CH combined with water in the presence of dilute H2SO4 and mercuric sulfate HgSO4 at 338 Kelvin. Yes. Okay. Now what happened here? The bond breaks. So automatically OH. Okay. So this OH which will go and attach with that carbon, this proton which will attach over here. According to Markovnikov's rule. Now you can bring it here, Markovnikov's rule. Even of course there also you can bring. But one point I wanted to mention there, that is a symmetrical carbon. But here unsymmetrical. Yes, now what is the product you will get it? Here what it is? I just mentioned here only. CH3, C, here OH, here double bond only. So here CH2, right? This hydrogen which is going to. Now this is actually what it is? Alcoholic formation. Whereas now what you will get it? Ketoenol tautomerization. Tautomerization. You will get acetone CH3 C double bond O CH3. See here, this is carbonyl carbon. This is what it is, alcoholic form. This is keto form. So they are asking what it is, propine into propanone. Yes, we got propanone. Hope you're clear with this idea. Alkyne converted into aldehyde as well as ketone. Okay, now you just check it, only ethine it is possible to give aldehyde. Other than that, everything, propine, butane, pentane, whatever it comes, that will give that keto formation. You please remember, related ketone, you will get it. Hope you're clear with this. Next question. How to convert aldehyde into acetal? It's so simple, you know. This is actually addition reaction. Aldehyde combined with alcohol 1:1 ratio in the presence of dry HCl. You are getting hemiacetal. That hemiacetal further it reacts with 1 mole of alcohol. You are getting acetal. Okay, come on, let us go for it. R C double bond O H combined with R O H. Right, alcohol in the presence of dry HCl. You are getting what it is now. You see this group OR which will go and attach over here. This hydrogen which will go and attach. So that means R, C, here OR, here OH, and here what it is? Hydrogen. Now again, what happened here? 1 mole of OH. So the same way which is going to attach here R, C, here OR, this point, okay. So here OR and then H. So this point which is called acetal, acetal, and this form which is called hemiacetal. Hemi means half. Hemiacetal. Right? You got it? How to bring this formation? And okay, we'll go for that particular formula. The same related concept but important question. Acetaldehyde into 1,1-diethoxyethane. Yes, come on, let us go for the same idea only. Yes, CH3, C double bond O, H. Combined with an addition reaction, no, that is alcohol, C2H5OH in the presence of dry HCl. Okay, so what you are getting the same idea only. I just bring it to your notice. So what happened here? This which is going to attach over here. So here CH3 C OC2H5. Here what it is? OH. Here hydrogen. So that means addition of aldehyde and alcohol. Both it is there. So one ethoxy. Ethoxy. See, ethoxy, ethanol, OL. See, 1-ethoxy ethanol. Okay, fine. Now, next to one, again, C2H5OH. So, what happened here? Water releases this one hydrogen and this OH. So, combined together, you are getting H2O. Now, remaining what it is? OC2H5, which will go and attach over here. So, that means CH3, C, here O, C2H5, again here down O, C2H5, and here as it is hydrogen. Now what is the name of this? Yes, what is the name of it? 1,1-diethoxyethane. 1,1-diethoxyethane. Okay, 1,1-diethoxyethane. I think you know very well how to get this kind of formation. Okay, addition of alcohol and aldehyde formation, it is acetal, right? Same like acetal, ketal formation also taking place. That means a ketone combined with the dihydric alcohol. That is monohydric alcohol, but here dihydric alcohol. So what is that? C double bond O R. Okay, this is like what it is, ketone combined with what it is, CH2. Single bond CH2, dihydric alcohol, ethylene glycol, no? OH. Here, OH. Okay, ethylene glycol, CH2OH, single bond CH2OH. I just put it ulta. You know why? What purpose? To just remove the water molecule. Okay, now just to bring the product, just remove that box automatically. You will come to know the form. Answer R. Yeah, R C. Here one R. Here O, here one O, here CH2, single bond CH2. Okay, so this is a cyclic compound of ketal. General formula only I just mentioned. Now we'll go for that particular formula. What it is? Acetone will go. This is a ketal formation. What we are bringing, it is a ketal formation. Okay, now CH3, C double bond O, CH3. These are all important questions only. Okay, combined with what it is? Here CH2, single bond CH2. Here OH, and the same way here OH. Okay, remove the water in the presence of dry HCl. Okay, so what happened here? You just remove that box, water box. So that means CH3, C, here CH3, here O, and here also O, here CH2, here CH2. This is a cyclic compound. Okay, now what is the name for it actually? 2,2-dimethyl, dimethyl 1,3 dioxolane, oxolane. Okay, so this is the name we can provide for this compound. It's a cyclic compound of ketal formation. Okay, hope you're clear with that acetal and ketal. Okay, now in this I wanted to mention one small mechanism. Here aldol reaction, that means CH3 C double bond OH combined with what it is, dry HCl, that means H plus ion. So it is protonates from the carbonyl compound, that oxygen. So protonated, what it is, alcohol formation takes place. It is very highly positive. So what you are getting what it is, nucleophilic addition reaction, nucleophilic addition product you are getting. So usually what it is, acetal or what it is, ketal. So whatever it is the product, it will undergo hydrolyzation reaction takes place. You will get respective aldehydes and ketones, you will get it. Okay, hope you're clear with this idea. So what product you are receiving means nucleophilic addition product you are receiving. The most expected question, aldol condensation. Generally, aldehydes or ketones are having alpha hydrogen. Okay, now aldehydes or ketones reacts with the dilute NaOH. What happen? Self-condensation reaction takes place. You will get beta hydroxy aldehydes or ketone formation takes place. Okay, now again if you heat, you will get what it is, alpha beta unsaturated carbonyl compound formation, you will get it. Okay, now this is CH3 CH2 C double bond OH. So this is 1 2 3, that is propanoldehyde. Yes, combined with again CH2 CH3, here CHO, in the presence of dilute NaOH. Okay, while heating, what happened here? This is CHO. Here also CHO. Now, which is alpha carbon, which is alpha hydrogen? Now, this is a functional group, means next carbon, this is alpha carbon. Already I mentioned. So, this is alpha hydrogen. Okay, this is alpha carbon and this is alpha hydrogen. Okay, now this alpha hydrogen, this also is having alpha hydrogen. Whichever is having alpha hydrogen is eligible for aldol condensation. Please remember. Okay, now next one. What happened here? I just put it a small correction here. CH2, I put it like this way. So what happened? This hydrogen which is going to attach over here. So here what it is, CH3, CH2, C, here OH formation takes place now. Here nucleophilic addition product. Yes, I wanted to mention this only. So here CH and CH over here. Here CH3. Here CHO. So what is the name of it? So this alcohol group also it is there. Aldehyde group also it is there. So here that means this is the functional group starts alpha beta. So that means a beta, it starts from there only 1 2 3 like. So this is alpha and beta. So this is beta hydroxy. What it is? Aldehydes. Aldehydes. So beta hydroxyaldehydes means what is the name you can provide? Okay, generally we can give the name 1 2 3. So 3 hydroxy, 3 hydroxy. Okay, 1 2 2. In that methyl group it is there. So 2 methyl, methyl, 1 2 3 4 5 pentanol, pentanol, Al, pentanol, Al. So this is hydroxyl group also, OH, and aldehyde group also it is there. So aldehyde and alcohol. So that is what? Aldol condensation. Okay, now, yes, while heating, what happened? Yes, I will write it here. Now, what happened here? In this, here CH3, the same thing, I just bring it here for you to understand. CH2, here C, here OH, here hydrogen, and a hydrogen, CH. This H only I just put it on the top. Why? To get that water molecules to release. Here CH3, CHO. Just I bring it on the top. Okay. You just put that water molecules box. So what happened here? You will get the double bond, the bond formation. You will get it. So you will get heating, that is very important symbol. So here CH3, CH2, here CH, no, CH double bond C, here methyl group, no, CH3, CHO. So what is it? Can you give the name for it? Here in this name, what is it? Very, very important. So there's this one functional group starts from here, no? So 1, 2. So 2 methyl pent, pent, 2 in. Okay, 1, 2. 2 in Al. 2 in Al. I just mentioned the underlining point what it is. Al meant for aldehyde. Here in also I just mentioned. So I hope you got a clear idea about if it is only alpha hydrogen is having, then only it will be possible to get this reaction. If they don't have that alpha hydrogen. So now for example, benzaldehyde and formaldehyde, is it possible to take Aldol condensation reaction? Put the answer in my comment box. Hope you're clear. Okay, now we are going to see that ketal formation, how to go for that condensation. As we have gone for the aldol condensation, now we are going for the ketal condensation reaction. Yes, for that we are going to take propanone, is also known as acetone. It is dimethyl ketone, anything we can say. CH3, C double bond O, CH3. In this, which is the functional group? Of course, this C double bond O, it's a functional group, carbon and carbon. Okay, combined with here CH3, C double bond O, CH3. Okay, now here you are taking that what it is, barium hydroxide. Barium hydroxide. Okay, dilute barium hydroxide solution. I just mentioned aldol and ketal both are ice. That means it's very, very important. I just mentioned in that way. Okay, now what happened? Now a small rearrangement, I just put it here. CH2H. Why? This hydrogen which is going to attach with this oxygen. This hydrogen, it is actually what it is. Now here, this is a functional group. Next to carbon, it is alpha carbon. This hydrogen, it is a alpha hydrogen. That hydrogen is having acidic in nature. So automatically it is going to attach. Yes, fine. Okay, that means H plus ion which is going to attach with oxygen. Yes, okay. Now what you are going to get? CH3, COH. Now this CH3, no, which will come down here, CH3. Now you see this CH3 will come down here. Why? This CH2 will go and attach over here. Okay, now here what it is? CH2, C double bond O, CH3. Okay, now CH3, COH, CH3, CH2, C double bond O, CH3. Now where is the functional group? This is the functional group. Now what is the name? Can you tell me? Here 4 hydroxyl, 4 methyl, pent 2 on, because double bond it is there. Okay, now what is the product while heating this compound? Okay, this is not completed. When we are going to get it complete, this is a ketol formation. Okay, this is ketone as well as alcohol. That is what ketone as well as OL, alcohol formation. Okay, while heating, what is the product you will get it? Okay, now a small rearrangement here. See, here one hydrogen. Just remove the water molecules. Here what happened? Bond formation. So what you will get it? CH3, C. Here what it is? CH3, double bond, because bond formation CH, C double bond O, CH3. So what is the name of it? 1, 2, 3, 4. So that means 3 in. So here what it is? 4 methyl pent, 3 in 2 1. Am I correct? 4 methyl pent, 1, 2, 3, 4, 5 pent, 3 in 2 on, double bond O, isn't it? So this is the name for this compound. Hope you're clear with this. Aldol and ketal both are very, very important. most expected question. Hope you're clear with that. In this aldol ketal formation, which is having that responsible means that alpha hydrogen, actually alpha hydrogen is having acidic in nature. As we are writing, you will come to know here hydrogen, hydrogen, here C double bond O, here H, carbonyl compound. Now what happened? This is a what it is, functional group. This is alpha carbon. So this is what it is, alpha hydrogen. This alpha hydrogen, actually what it is, acidic in nature. Acidic. So what happened? It releases the proton, H plus ion it releases. So what happened actually? R C here. Anion formation takes place. So when it releases the proton, anion formation takes place. C double bond O, here H, here hydrogen. So this actually dissociates the bond. So bond dissociation takes place and resonance takes place. So it is stabilized in that way. So you will get what it is. Here R C, here double bond you will get it R C H here. Here see here O minus. So due to that resonance, it is stabilized. So this acidic in nature of alpha hydrogen only is the responsible for aldol ketal formation. Hope you're clear with this. Thanks for watching.